Math is an important part of programming, not necessarily C-sharp programming, but programming in general. It really doesn't matter what language you're using or what application you're writing, but somewhere, somehow, mathematical calculations are going to come into play. Now, those calculations could be something very simple, or they could be something very complex. I know in my daily writing, I do have to generate some PDFs or work with graphics, or sometimes generate a report that gets sent to the printer, and those are calculation heavy. But unless if you're doing something like that, the amount of math that you have to do is rather light. So I do know that some of today's lesson is going to be boring, for the lack of a better word, but please don't write this lesson off. Yes, we are going to be covering math, but there are a couple of other topics. One is comments, which are really easy, but the most important is going to be memory management, because the .NET framework handles memory differently for different types of data. We're going to talk about value types today, and there's another type of value called reference types, which we will talk about whenever we start writing our own classes. So let's get started today with just some simple math, and really we're just going to blow through this because math in C# is very close to the math that we learned in school. So let's start. I'm going to create a variable. It's going to be an integer, and it is going to have a value of 2 plus 4. And what actually happens here when this code executes, foo, the variable foo, is given a value of 6, because naturally the application is going to take 2 plus 4 and take that result, which is 6, and assign that to foo. Now, if you'll notice, I typed 2 slashes and then a space and a 6 after. Now, the space is optional, but this is what is called a single line comment. Comments are just for our use or somebody else that is reading our code. They are completely ignored by the compiler. So we can just type all day long of gibberish, and it's really not going to matter because it's all going to be ignored. So it's really helpful, especially if you are writing some code that is difficult to follow. And I can speak from firsthand experience that I'll write something and then 6 months to a year later I have to go back and look at that code and I'm wondering, what did I write? Why did I do it this way? Well, that's why comments are here, so that we can type something out to give some type of insight as to what type of voodoo that we are doing with our code. Now, this is a single line comment, so anything after the double slash is going to be considered a comment. But we do have a multi-line comment, and that has a slash followed by an asterisk, and then Visual Studio is automatically adding in those other asterisks as I press enter. But then to end a multi-line comment, you do an asterisk and another slash. So it's kind of like an HTML tag, but not really. At least that you have a beginning, which is a slash asterisk, and then an end, which is an asterisk slash. And then anything within this little block of comments, and these asterisks really don't mean anything, but anything in here is a comment, so it would be completely ignored by the compiler. As to which one you use, it really doesn't matter. I've seen more single line comments used than multi-line. In fact, there is a keyboard shortcut. If you hold down Control K and then C with keeping Control still held, it will comment that line that you're on. So if you have multiple lines, let's just add multiple lines, and if we select them all, we can quickly comment them all out. And then if you want to uncomment them, you press Control K, and then while still holding Control down, you press U. So that's a nice little nifty feature of Visual Studio. Okay, so getting back to our math here. On the right-hand side of the equal sign, that would be called an expression. We have, in this case, a mathematical expression, 2 plus 4. And it is primarily executed from left to right. So it takes 2 and then it adds 4 to it. So if we add another addition operation here, it's the same thing. It's going to take 2 plus 4, which is 6, and then it's going to add 1, which is 7. So that changes to 7, and then just to finish this off, let's add 3. So we'll have 2 plus 4 is 6, plus 1 is 7, plus 3 is 10. So it goes from left to right. And the order of operation is the same for subtraction as well. If you remember from math, there was the mnemonic for the order of operations, multiplication, division, or addition and subtraction. Well, that applies here as well. The multiplication and division are on their own level of precedence, which is the technical term, and then addition and subtraction are on a lower level of precedence, but they are on their same precedence. So we haven't really changed anything as far as what gets evaluated before the others. So it's still 2 plus 4, which is 6, but now it's doing the minus 1, which is 5, and then plus 3, which is 8. But if we change one of these, let's change that to multiplication. In C#, the multiplication operator is an asterisk. It's not an X because, X is an alphabetic character, which is typically some type of identifier, either for a variable or for a method. So it's an asterisk for multiplication, and now the order of operation has changed because multiplication comes before addition. So now it takes 4 times 1, which is 4, and then it does all the other addition operations. Now we can change the order of operation by using parentheses, just like in math. So in this case it would be 2 plus 4, which is 6, times 1, which is 6, plus 3, which is 9. And of course, we could also do that, which then it would do the expression inside of the parentheses first. But it would do 4 times 1, since that is multiplication, which is 4, plus 2, 6, plus 3 is 9. So, really, that's really it as far as math is concerned. Let's just do division. It's a slash, and that's it. It's just like the math that you learned in school. Okay, so math and comments are done and out of the way. As I said at the beginning, those are going to be really easy. So now let's talk about value types and a little bit about memory management. Not necessarily memory management, but how these values are stored in memory. Yesterday I said that there are 2 categories of data types, primitive and complex. Well, there's another set of categories. One is value types, and the other is reference types. And all of the primitive types that we talked about yesterday are value types. So integer, floating point, double floating point, decimal, character, and Boolean, all of those are value types. And there's even more value types, but I'm not going to go over those now. I'll just point them out whenever we work with them in later lessons. So why is the term value type value type? Well, it's because of how it is stored in memory. The actual value is stored in memory. So we have a variable called foo, and remember, variables are just boxes of memory. So we have foo equals 10. So the foo variable contains the value of 10. I know that seems like I'm being Captain Obvious, but it's very important because reference types are stored completely different. Okay, so value types are stored by their value, but they are also immutable, and that means that they cannot change. So 10 is assigned to foo. That 10 can never change. And to illustrate that, let's do int bar equals foo plus 1. So what we have here, and I know once again that this seems obvious, but foo is not changed at all in this new line of code in line 13. Let's look at the expression, the right-hand portion after the equal sign. We have foo plus 1. Well, we're not actually using the direct value of foo here. A copy of that value is made. So a copy of 10 is made and used in place of foo. So it's a copy of 10 plus 1, which of course is 11. But it's obvious as to what happens, the result at least. But the copying issue isn't. And the copying is being done because it's immutable and it's being done behind the scenes, so you don't even have to worry about it. Now, I said that these values are immutable and they cannot change. But you can change the value that a variable contains. So, for example, we have foo equals foo plus 1. Now, the same thing is happening here. On the expression side, foo is being used, but in actuality, a copy of that value is being used. So a copy of 10 plus 1 is 11. So foo, after this line executes, is going to contain the value of 11. And in order to do that, the original value of 10 had to be destroyed. So it was completely removed out of memory, and then it was replaced with a new value of 10. So even though we used it in our expression, that didn't change the value of foo until the actual assignment was done. So I know that it seems rather obvious that, yes, we are working with the actual values here. But whenever we talk about reference types, and we're not going to do that today, but later on, whenever we talk about reference types, that is definitely not going to be the case. Because they are stored completely different in memory, and they have to be handled differently as we write our code for them.